Okay, so let's finish this part then now. So Thursday morning actually we will have, maybe Thursday morning or any other time also on Thursday, whichever is convenient to you. Okay. I think we were discussing about traditional methods in the previous class. This part is done. Last class anyway, the attendance was a bit poor, about 30-35 people only they were there. Anybody who has not gone through this particular part? Who were absent in the previous class? If all of you are there, then I'll go to the next part. Otherwise, just quickly I'll take you through. These are anyway self-explanatory. These 5 different methods are considered as traditional methods of pre-milling treatment. These are not the
Sir,
methods
what
of
will be the
parboiling.
pattern for test? Sir, pattern for test.
Pattern for test actually, some objective you can actually fill in the what is that called? Google form or maybe MS Teams form itself. And a couple of them you may have to solve and upload the solution. Maybe some numericals will be there, some write-up will be there.
Okay, sir.
Okay.
Thank you, sir.
Yeah. So this first 2 and the last one, these 3 are originated. Atappa, Balam and Siddha. These 3 methods are originated in Bengal. Bengal means the combined Bengal when East Bengal and West Bengal was together. And second one is developed in the Pakistan. And fourth one, Sela, which is actually originated in India, where is actually most commonly used in the subsequent days all over the India. Paddy was soaked for 24 to 48 hours, subsequently gently roasted using hot sand at 18 to 90 degrees centigrade. This will be helping in completing the gelatinization process with sufficient amount of moisture absorbed by the kernel, followed by, and this process anyway will be reducing some amount of moisture content while it is being exposed to 80 to 90 degrees centigrade, and the residual moisture content will be reduced by sun drying, and subsequently the grains are milled. Okay. So the Siddha process, of course, it was even developed beyond your Atapa and Balam, where the paddy was soaked for 20 hours. Then it's boiled. Instead of roasting with sand, it is actually boiled for a few minutes. That will be completing your gelatinization process. However, the moisture content will not be reduced, or maybe 1 or 2% variations will be there, either positive side or negative side. Then, whatever the moisture content is present in the kernel will be reduced using the sun drying process. So that means in most of the traditional methods of pre-milling, the drying method was sun drying. And of course, the quantities even treated, these were actually limited to the family requirements. Probably these were not really done on a commercial basis that time. Okay. Now, if you see the real parboiling, what we were discussing about. So as I mentioned, parboiling, the definition itself, it says it's partial boiling. It is the latest pre-milling treatment that improves the quality of the rice. The what kind of quality? Maybe if fissures and cracks are there, those will be sealed, and the kernel strength will be improved, and that way actually we can improve the milling yield. And apart from that, even the water soluble minerals and vitamins will be infused into the inward layers. That's why the parboiled paddy, or maybe the parboiled rice, is more nutritious compared to your raw rice. Another thing we have discussed is the rice bran obtained from the parboiled rice. It is actually containing higher amount of oil, 25 to 30% of oil it contains. This is because during your steaming treatment, the lipids will be thrown to the outward layers. So that means mostly these will be concentrated in the bran layers. So this is again the outward diffusion basically because of the lightness or maybe specific gravity changes. Okay. So this way the oil layers will be moving in upward direction, or maybe the outer layers it will be concentrating. The water soluble minerals and vitamins will be infused. So that's why grains contains, sorry, the kernels or maybe the rice contains higher nutritional value, and the bran contains more amount of oil. Now, as I mentioned in the earlier cases also, it is the hydrothermal treatment followed by a drying before you go for the milling. Any clarifications required? I think otherwise, all of you please kindly mute. So this parboiling traditionally, and of course, it is actually after improvement from these methods. It's not the same as, but these are actually improved way. So in this case, it is done in two different ways. Conventionally, the parboiling is done in two ways. The first one is called single boiling method. The other process is called double boiling process. In case of single boiling method, paddy is soaked in cold water for 24 to 72 hours. That's 1 to 3 days. And this process will be adding the sufficient amount of moisture content until its saturation. Then it is steamed in the usual manner. It's like actually open steaming, but it's done for some time. Now, in this case, since you are uh, soaking it for a long period, like 24 to 70 hours, this develops bad odor due to the prolonged soaking. So that means the soaking time is more, and which will be causing some kind of bad odor, and even sometimes some kind of putrefied smell will be there in the rice resulting also. So to avoid that one, subsequently people have developed double boiling method so that you can reduce the soaking time. Now it involves double soaking in sequence of operations. So sequence of operations means even before soaking also once it is steamed, and after soaking completion also it will be steamed once. That's why it is called double steaming. In the local language, single bapa, double bapa. Mana do bapa, egg bapa. Egg bapa means one time it's steamed. Do bapa means two times actually it's being steamed. So double steaming. Now these are actually carried out in a specially designed vertical steaming kettles. They are having certain dimensions like 0.7 to 0.9 meter dia and 1.2 to 2 meter height of these conical bottom tanks. These conical bottom tanks are as shown in the previous slides in some of the in one of the classes. So it is vertical cylindrical, and at the bottom actually you are having a conical bottom, right? So this way these kind of containers are used for steaming purpose, and the steam pressure in the boiler is maintained around 6 to 7 kg per centimeter square. In turn, you will be getting about 2 to 4 kg per centimeter square for the steaming purpose. Now, the steaming is done in the masonry tanks. Unlike in the modern methods, I think I have explained about CFTR method of parboiling. So in the CFTR method, we have seen this soaking and steaming is done in the same tank. But in this case, the soaking is done in the masonry tanks. These are actually built with brick and plaster, and such kind of large tanks, 20 to 35 tons. That means the whole batch of the metal is soaked in a single large tank, which is made of masonry work. Now, paddy after steaming for about 3 to 8 minutes, these are used for steaming. 3 to 8 minutes. These are actually dumped into soaking tanks. That vertical masonry tanks are there. So these are dumped into that one. And there's a cold water which is already filled in. Now the soak water temperature of 70 to 80 degrees centigrade initially when the mixer is dropped. Like actually when the steamed paddy is dropped into that one, the mixer temperature will be about 70 to 80 degrees centigrade, and that will be dropping to 50 to 60 degrees centigrade within 2 hours. So this is actually a common process by mass balance which is happening. Okay. Now this paddy is soaked for 24 to 72 hours. Generally, since you are heating, 72 hours is not required. Only some varieties which are thick and short varieties, which are called, where actually the diffusion characteristics are a bit poor. In those cases only, in the two steaming process is maintained for 72 hours, but otherwise it will be completed within 24 hours in most cases. Now the soaked paddy is now after 24 hours is lifted back to steaming kettles, as I described in the above this thing, vertical steaming kettle which I mentioned. There actually it is taken once again, then steaming is done the second time. So here also, depending upon the size of the tank, so 3 to 8 minutes of steaming is done. Then subsequently the steamed paddy is taken out after removing all the condensate. This is actually dried in either drying yard or maybe mechanical dryers. So that time actually in the earlier days, the mechanical dryers also, these were actually batch type most commonly available. However, later days actually people have developed some kind of continuous dryers like LSU dryer, etc. Those are being used. But however, the process consists of 2 times steaming and followed by your drying. Am I clear to you? This is actually the pictorial view of the the parboiling process, where the raw paddy is taken and it is dumped into uh, steaming tank. If it is a two steaming process, that means before soaking also you are actually steaming once. So in that case, it is first loaded into, just a minute. This is first loaded into steaming tank, number two. Then this paddy is taken to number three is your masonry big tank, that 30 to 35 tons tank, right? In case if you are following the single steaming process, this is simply taken the path A and dropped into the masonry tank. So here actually the cold water is already loaded, and without any steaming, it is dumped into this one and left it for 24 hours to 72 hours, depending upon the diffusion kinetics. Then after that, this soaked paddy is and taken and lifted back to your kettle, which is actually the steaming kettle. So this pipe, which is actually having perforations, this is called steaming pipe, and this is connected to a boiler, and through which actually the steam is distributed in the bulk of your grain here, number two tank. So after completion of the steaming, then it is taken to the drying in this way, and of course sun drying is generally followed. So in case of double steaming process, it is steamed once and this paddy is dropped into this one. After soaking, once again it is lifted back to the steaming tank. The second steaming is done, then it is followed by your sun drying. I hope I'm clear about single steaming and double steaming, guys.
Yes, sir.
Yeah.
Yes, sir.
Yeah. So moving further, so after the single steaming and double steaming methods were developed, and in search of actually better quality or maybe good quality without having any kind of bad smell, without having deeper colors, etc., people started researching, and there actually they have developed a lot of modern methods. So these modern methods of parboiling are listed like this. So the improved parboiling method of CFRI, which is a batch method, of course, so developed in India. Then the Schule process, which is developed in the Germany, and this is also a batch process. Crystal rice process. Since the parboiled rice looks like a translucent crystal, that's why the process is also named as crystal rice process. Then in UK, this has been developed in the Italy, which is also batch method. There is another process called rice conversion process, where actually the starch which is ungelatinized is converted into gelatinized starch. That's why the rice conversion process they named in the UK, which is also a batch method. And another improved method which is developed in India is improved parboiling methods of Jadavpur University. This actually they have developed like a semi-continuous, and there is another method which is a continuous method also. Okay. Then we have Rice Growers Association of California parboiling process developed in the USA, which is also a semi-continuous process. And you have, of course, the list is a little longer, not of course very exhaustive. Then we have Avoria process developed in the Italy, which is a continuous process. There's the Fernandez process developed in Suryam, which is also a continuous process. There is another process, ERI, there's the International Rice Research Institute, Philippines. So this, of course, when it was listed, it is under study. There are actually a couple of what I can say reports are there where this process is being commercialized now. Now we have a true continuous parboiling process of Jadavpur University, which is also developed in India, and this was actually under study, and a couple of trials, of course, people have published. Now, one method which is developed at IIT Kharagpur itself, which is called RPEC method, Rice Process Engineering Center. So this RPEC method is developed at IIT Kharagpur itself. Then we have one sodium chromate method developed in India only. In fact, this method has been developed for the purpose of minimizing or maybe avoiding these putrefying smells during your soaking process. So when you go for sodium chromate addition in the soaking water, that will be stopping all these obnoxious smells development or maybe any kind of bacterial growth that will be arrested. So that's why this this process has been developed. Now brine solution method is another one. This is actually commonly used for preparing your puffed rice preparation. So this brine solution method is not for the edible rice, but it's for your puffed rice, which we call murmura. So murmura actually comes from the rice only due to a process called puffing. So before puffing, the rice has to be prepared. So for that, actually, this is generally followed. Similarly, we have Kisan continuous parboiling method. It's also developed in India. And another method, pressure parboiling method. Again, this method also for the purpose of puffed rice preparation, not for the edible rice. Okay, not for the rice consumption purpose directly. Okay, so these are actually methods enlisted. However, we will be discussing only a couple of them, like whatever is highlighted, like improved parboiling method of CFTRI. Then Jadavpur University methods, both semi-continuous and continuous, we'll be discussing. Pressure parboiling also probably I'll be taking you through. Okay. Now, if you look at improved parboiling method of CFRI, this is aimed at improving the both yield and as well as the quality of the rice with low capital investment. So, how low capital investment you are calling? If you can use the tank both for steaming as well as soaking purpose, so automatically some of the cost will be reduced, right? Secondly, if you can reduce some amount of moisture content during the pre-process, so probably the drying cost also can be reduced. So that way, they have tried to optimize the whole process. That way, you can actually have low capital investment. So soaking and steaming is done on the same mild steel cylindrical tank as I mentioned, and the steam enters through central perforated pipe and distributed through radial pipes. I'll show in the next slide how this perforated pipe, which is a special design basically, so that uniformly in the entire volume of the vertical tank, so this will be distributed so that no location will be excessively steam and no location will be under steam. So this way you will be having a kind of uniform steaming in the whole tank. Now, during the parboiling process, the water is heated through steam up to 85 degrees centigrade, and this paddy is poured into inside the tank. So then this water which is there at 85 degrees centigrade now is added with the paddy in cold condition. So now this mixer temperature drops to about 70 to 75 degrees centigrade. Okay. In the double steaming process, what we are doing, so you are steaming the paddy and dropping into cold water. But in case of CFTRI improved method, the water is heated and there is actually separate water tank for the hot water purpose, which is actually prepared using the steam only. Or otherwise, in the same steaming tank, you can load the water, release the steam for some time so that the temperature is maintained to 85 degrees centigrade, followed by your cold paddy dropping. This temperature of mixer will be dropping to about 70 to 75 degrees centigrade. Now, with this temperature, the circulation of water is maintained. After 2 to 3.5 hours of steeping, basically the soaking is also called as steeping. So now the steeping water, the residual water is called steeping water, that is drained off, and the steam is passed through the paddy bulk until the husk begins to split. So this is actually the end point. Those who don't know also, this is a kind of thumb rule, or maybe you can say end point, how actually it can be taken. Now, after the steaming, hot paddy is unloaded through bottom hatch and spread over drying floor to cool down and maybe remove the moisture content. So if you are following the sun drying process, this will be spread in a very thin layer, or if it is followed with the mechanical drying, then after cooling down, this paddy will be loaded to your LSO dryer, Louisiana State University dryer. There actually it is dried until the moisture content is brought down to 12 to 14%. However, the drying process is commonly in case of mechanical drying particularly is done in 2 passes. So 2 passes means are better actually if you go from maybe in more passes, multiple passes, but at least 2 passes. That means the 50% moisture content on dry basis will be brought down to around 16 to 20% in the first stage. Then some tempering is done. The tempering will equilibrate the moisture content within the grain bulk as well as within the kernels. So that way the dry rate will be improved. Then this will be of course useful in terms of minimizing the stresses, in terms of minimizing the brokens. And of course the second pass will be reducing the moisture content from 20% to 14% on a dry basis. So this is how actually it is being done. Now if you see, this is the process of course in a simple pictorial way. The raw material is taken here, the raw paddy, which is actually dropped into the soaking tank, where the water is actually maintained at low temperature and the hot paddy is dropped, or otherwise the water is at hot condition and drop it with the cold paddy. So this way the soaking is done in a soaking tank, and followed by the steaming is done after removing all this excess water, which is called steep water. So the steep water removal followed by steaming will be completing your gelatination. I'm just repeating again, the soaking process will be facilitating the grain to absorb the moisture content up to its saturation point, which is called saturation moisture content (SMC), which is generally about 35 to 50% on a dry basis. And of course, the higher levels are maintained so that there will not be any kind of white belly or maybe incomplete gelatinization process. Now, in presence of this saturated moisture content, if you go for steaming, so that will be compensating your hydrothermal process. This thermal process is being taken care here, and this temperature will be completing the gelatinization process. So this way, the starch will be converted from amorphous form to your crystalline process. Now, this paddy after steaming is done is dried using appropriate means. Maybe it is a sun drying or maybe it is a mechanical drying. Now, as far as the steaming tank is concerned, this is a special design as I mentioned. So this is the steam pipe which is actually coming in, and this is actually connected to a network of pipes. So if you see from one side, this looks like there are 5 fingers, whereas if you see from the top, so similar cross connections also they are there, so that this location, this location, this location, these are equidistant from center. Similarly, this discharge inlet output and this discharge output, these are actually in another outer ring. So this way, all the corners of steaming tank will be reaching the steam without any unequal distribution. Even let us say this bottommost, since this some portion of tank is there, so this has been extended. So according to the tank also, the length of these distributing pipes have been arranged. So this way, with this kind of network, you will be able to uniformly distribute the steaming. So you have to remember this such kind of special arrangement is necessary. Now there is a water discharge gate valve is there. So if you are using the same tank for soaking cum steaming, so initially the water is loaded into this one, release the steam, you maintain the temperature to 85 degrees centigrade. Now drop the paddy into this one. Now this will be dropping to 70 to 75 degrees centigrade. So it is actually allowed to soak for 3.5 hours around. Then afterwards, the water is discharged through this perforated outlet. Actually, here there is a wall. If you remove this one, so through these perforations, only the water can enter into this wall, and the water is discharging out. Now, after this, again you go for steaming. Now, soaked paddy is inside only. Again, you go for the second steaming. That's called actual steaming operation. Then there is some amount of condensate generated when you are using the steam. So that will be again discharged through your water this outlet. Then finally, the grain is actually discharged through this kind of sliding gate at the bottom. So this angle is maintained at a minimum of 45 degree. This hopper angle is maintained a minimum of 45 degree. Higher the angle, and it is easier to discharge the grain, because the parboiled grain being a wet in condition, it will be having higher cohesiveness. So if you have less than this 45 degree angle, discharging the grain will be difficult. So that's why it is 45 degree and above are generally maintained. For a better facilitation, a 55 to 60 degree angle is commonly used. Okay. Am I clear to you guys? Am I clear to you about this one? This is very important as such.
Yes, sir.
Yes, sir.
Now moving further, you can see here, this is the soaking time and this is the moisture content on dry basis. How actually we are starting? This 14 or 15% are, this is the initial moisture content of the paddy which is harvested and stored. Okay, we are starting the soaking from this particular location. As we drop into water, the moisture content of the grain will quickly grab. Within an hour, I think it will be grabbing almost more than 35% of the moisture content on dry basis. So the first stage of soaking is generally done around 80 degrees centigrade. You can say 75 to 80 degrees centigrade. And followed by, in the second stage of the soaking, the temperature should not be high. It should be less than or maybe close to your gelatinization temperature. I think I mentioned in the previous class, each grain or maybe each variety will have a particular gelatinization temperature. But on an average, a paddy is having 72 degrees centigrade as the gelatinization temperature. So this will be maintained below that one. So in the second stage of soaking, already it has come to very high moisture content. From here on, even at 70 degrees centigrade also, even at 70 degrees centigrade also, so this will be able to reach to the saturation moisture content, but it will take a little long time. Now let us say, somebody may say, sir, can we not reduce the soaking time by having the same 80 degrees centigrade? Yes, you can. So in that case, actually, it will be sharply taking in upward direction and may not stop at 45 or 50% moisture content. So some of the grains will be bursting and they will be absorbing excess of moisture content. That means the structural integrity will be lost if you are going beyond gelatinization temperature at the time of completion of the saturation or maybe at the time of completion of the soaking. So that's why it is maintained close to 70 degrees centigrade for the second stage of soaking, although it is taking a little longer time. Now, as I told, so this will be taking about 2.52, so 3.5 hours around. So by that one, you are actually achieving your required moisture content. So this here actually the SMC or saturated moisture content for a specific variety is taken as 42.7. That means beyond that, probably it is not going very easily. So that's why they have stopped or maybe considered as a highest moisture content of 42.7 degrees, percent dry basis. Okay. Now, this is actually combination soaking means basically the heat and water, and that too actually two different combinations are being maintained. That's what actually it means. Am I clear to you? Am I clear to you?
Yes, sir.
Yes, sir.
So this particular level of moisture content is called SMC or maybe saturation moisture content, which will be anywhere between 35 to 50% moisture content on dry basis. But in this particular case, this variety, the saturation moisture content has been attained as 42.7 on an average, right? Now, this is actually the pictorial view of a modern commercial parboiling unit, where I think I might have shown earlier, these are actually holding bins where actually the clean paddy is loaded into this one and kept ready for your parboiling process. So on the top, actually, you are seeing some small tanks. These small tanks are called steaming tanks. So these steaming particularly is done for the raw paddy. So the raw paddy is steamed and dropped into the cold water in this larger tank. This is actually anyway soaking cum steaming tank, but the paddy is actually steamed here for about 2 minutes and dropped into this one, so that the mixer temperature will be raising. So after completion of the all the batches, like actually after filling completely, then the water mixer, water paddy temperature mixer will be about 70 to 75 degrees centigrade around. So this will be held for 2.5 hours or so. Then the water is drained out from the bottom tank. Now the paddy is in this only. Now, in some of the cases, the second steaming is done at the bottom with the help of another set of similar small tanks. One advantage with the small tank is you will be finishing the steaming process in 2 to 3 minutes, and the excessive heating of the grain will not be there. Thus, the imparting of this yellowish color will be less. Whereas, if you do the steaming in the same large tanks, this will be taking about 20 to 30 minutes. If you remember, actually, I have mentioned the time, 20 to 30 minutes it will be taking for the large tank. So 30 minutes if you are steaming, maybe the paddy which is very close to those steam pipes, so they might be excessively heated up, so the color will be very much dark. So that's why such kind of double steaming but using small tanks is preferred in one of the improved methods of parboiling. Okay, otherwise you don't require the second tank at the bottom. So this soaking cum steaming tank itself can be serving the purpose. So by avoiding this setup and this set of tanks, so the improved method of seat tire method, they have actually reduced the cost of infrastructure. Okay. Now this paddy, after completion of the steaming, will be dropped onto a conveyor belt at the bottom, and that will be dropped this end, and from here actually there's a bucket elevator which is lifting to the top and dropping into this dryer. So this is your LSU dryer, where you are having two major sections. So this bottom section is your drying bin, and this top portion is called holding bin, and this portion is your plenum chamber, followed by there's a blower here. However, so this is the black color one what you are seeing. This is a kind of heat exchanger. So this heat exchanger will facilitate the air to heat up, and that hot air will be distributed through this plenum chamber into the entire vertical section of the LSU dryer. So after completion of drying in number of cycles, like actually the paddy slowly it will be moving to the bottom, and again it is recycled through your bucket elevator here. So this way, maybe 2 to 3 times this will be circulated, so that the dried paddy will be going down and of course coming up. So this way there is a tempering time also it is facilitated. So this way the unification or maybe equilibration of the moisture content also has been facilitated. So this way the LSU dryer will be able to complete the drying process to remove the moisture content from 50% or maybe 45% of the dry basis to 12 to 14% on dry basis, which is actually a safe, storable and milling moisture content. Am I clear to you? Am I clear to you?
Yes, sir.
Anybody is having any doubts until now?
No, sir.
Okay. Further, this is the improved method of Jadavpur University method, where the process is partly continuous. That means some of the operations are continuous and some of the operations are in batch. That's why it is called semi-continuous. So, okay, that's partly continuous. Now, the steeping is done at 70 degrees centigrade within 2.5 to 3 hours in vertical cylindrical tanks. So, steaming is done in the same tank, having perforated steam pipes for 3 to 5 minutes, as I showed in the previous pictures, how the steaming tank perforated pipes are distributed. So that way, it is actually steaming is done for 3 to 5 minutes in small tanks. Then after steaming, the paddy is rapidly cooled in a cup and cone dryer. So this is a kind of additional feature in case of Jadavpur University method compared to your CFTR method. This will be facilitating cooling down of the paddy, because under the hot condition and moist condition, if the paddy remains for a little longer period, like in a stagnant position, then the color of this husk, yellowish, that will be transferred to the kernel. So the kernel should be more yellowish or maybe darker. So that's why to avoid that one, so they have actually facilitated rapid cooling in a cup and cone dryer, which is again a kind of pre-drying process. So this will help to maintain the lighter color. First advantage. Second advantage is the drying time will be reduced because the moisture content partly has been already removed. So that's why this will be taking a less time in case of your subsequent drying steps. Now the paddy is dried in a steam tube rotary dryer at 90 degrees centigrade. So they are using a rotary dryer, which is again a kind of continuous dryer. So that's why your soaking and steaming might be batch process, but your drying is actually kind of continuous process. That's why this is called partly continuous. Now the paddy is tempered and cooled before milling. So maybe after removing the moisture content, since you are using a 90 degrees centigrade, again this may cause some kind of stresses to the kernel. So to avoid that one, the paddy is tempered and cooled in between, and even at the end of the process also, before it's being milled. So this will be cooled down to a normal ambient temperature, and subsequently it is sent for the milling purpose. Okay. Now these are again examples of your Jadavpur University method, where actually the steaming tank is on the top, then the steamed paddy will be dropped into the soaking tank. Again, after that, the second steaming is done at the bottom with another tank. Okay, and in the improved method, actually, instead of actually steaming here, so they have taken hot water as a means of soaking. That hot water is taken instead of first steaming. Only the second steaming is done either in the same tank or maybe with a separate tank at the bottom. Okay, so this is actually generally which is being followed. Now, if you see the drying as a third step of parboiling process, so you can do a continuous drying also. You can do a partial drying followed by tempering, etc. Then there will be a possibility of fissures development if you are continuously drying. Although it takes less time, so it may be developing some kind of fissures and cracks. But if you see, if you go for tempering, the overall drying time will be lesser than a continuous drying step. That means the energy which you are spending for the purpose of drying will be lesser when you go for multiple or maybe at least a double pass. So you can see here, so the initial moisture content was 53.69% on dry basis. The critical moisture content where you are stopping the first step is 20.48% moisture content on dry basis. Now the drying area velocity is about 6.5 meter per second. That means when you are stopping at critical moisture content, you are allowing the paddy to temper it, and the second stage moisture content removal is from 20 to 14% moisture content. Now you can see here, so the blue line, if the first pass is continuously at 50 degrees centigrade, whereas this part, the bottom part is actually the second pass. After holding for some time, the second pass actually it is done with the same temperature, for example. Okay, so here actually because of the tempering, the time required overall for the drying will be lesser, and of course you can save the grain from the cracks development. Similarly, if you see the 70 degrees centigrade, so this is your continuous drying, whereas the second pass means if you are stopping it here and allowing it for 100% tempering, there of course you are starting here, so it will be starting with a lower profile moisture content, and overall the time required to reach a particular moisture content will be less than continuous method. And similarly, the third part you can see, if you are going for 100 degrees centigrade without tempering, so this is actually, although it takes less time, but 100 degrees centigrade without tempering means lot of brokens will be developed. But when you go for tempering, the profile is beneath this one. That means it will be taking maybe at the same time of drying, if you see, the tempered grain will be having a lower moisture content compared to your continuous drying. So this way you can save the energy, at the same time you can save the grain in terms of improved milling quality. Am I clear to you guys? Tempering is a kind of holding in a enclosed bin so that the moisture unification within the candle and within the total grain bulk will be happening, and by that way the next stage of moisture content removal will be very easier. Like you don't require to the drying rate will be improved. Okay, maybe in the next class, if time permits, I will be showing how actually the kernel. For example, you assume like this: you have a sphere. So in the sphere, actually, when you are trying to dry, so what will happen? The first and foremost, the outermost moisture content will be removed. Is it not? So now, subsequent time, maybe after half an hour, 1 hour, or maybe 1.5 hours, the moisture content is now mostly concentrated in the innermost layers, whereas the outermost layers are actually dried up. Okay. So now, is it the same way it can be dried from the inner layers? No, there will be a lot of obligation for the moisture movement from the inner layers to outer layers, because there is a diffusivity issue, there is a hardness issue. That's why actually the moisture cannot easily remove. Okay, so that's why actually if this innermost moisture, particularly the central core, what we call, that moisture content to bringing to the upper one, it will take its own time. In spite of having a very high moisture content, very high temperature adoption also, the moisture content may not diffuse so fast. So that's why we need to hold it for some time, so that under the holding period, the moisture content slowly will be diffused into the outermost layers because of the concentration difference. Because the outermost layer is having a very low moisture content, the innermost layer is having a higher moisture content. Due to this concentration gradient of the moisture contents, that will be diffused, and of course, so now either distributed or maybe coming to the top layers. So now in the second pass, when you are starting the drying, so it will be taking a, it will go down very fast rather than actually going this way. Okay, so that's why the saving in the time, saving in the energy, and saving in the quality will be possible with the two-stage or maybe multi-stage drying. I hope I am clear to you, guys.
Yes, sir. Yes, sir.
Yeah. Moving further, we have a true continuous parboiling process of Jadavpur University. This process is based on a true continuous system. That means maybe the soaking, steaming, as well as your drying. All the three modes will be mostly done in a continuous process. That means one end you are loading the grain, maybe other end you are getting the dried grain. So this way the whole process would be continuous. So it consists of a continuous vertical soaker. So that means vertically the grains will be moving in a number of trays or maybe some kind of layers. So when it is moving in a slowly in downward position, so due to this residence time which is provided, the soaking will be completed. So this is called continuous vertical soaker. And the second step is continuous horizontal steamer. So maybe a kind of conveying system or maybe screw conveyor might be there, where actually the grain is moving, the soaked grain is moving continuously, where actually it's being steamed. So that way the continuous horizontal steamer will be finishing your steaming operation in the second stage. And a continuous fluid bed dryer, that will be your dehydrating or maybe drying your grains continuously. Then we have a continuous vertical conditioner. Basically, conditioner means that kind of the way actually we are talking of tempering. So this conditioner is basically for holding grain in a small pockets, and so that some time elapsed will be there. That way the unification or maybe equilibration of the moisture content will be happening in the conditioner. Finally, so there is a cooler. So this cooler will be removing the moisture, removing the temperature, so that the grain will be at ambient condition when it's coming out. This way, all these different sections in continuation will be making the system true continuous. Now, the time and temperature of the soaking and steaming, these can be controlled according to the movement of the grain with the systems which are actually adopted. Now, the residence time in the dryer, conditioner, and cooler, they also can be adjusted according to your cycle which is required, because it has to match with the soaking and steaming. Drying cannot actually work independently. Although the drying process is slower compared to your soaking and steaming, but these three steps are to be matched, then only you will be having a true continuous process. Otherwise, there may be some stagnation or maybe there may be some kind of underflow. So then it cannot be considered like continuous. That's why the residence time uh, in a dryer, conditioner as well as cooler, they also can be adjusted so that it will be matching with your soaking and steaming. Am I clear to you? Now maybe I think this is a schematic of that one, the flow diagram of Jadavpur University method. In fact, the first part without moment of any kind of paddy. So this will be your semi-continuous process where the paddy is soaked and steamed in a combined tank. So it is dropped into this one, steam is released, and maybe water and this grain mixture will be heated up and it is allowed to soak for some time. Then the water is recharged in the same tank. You will be steaming once again, and the steamed paddy will be going to your cup and cone type of dryer for the partial drying purpose and cooling purpose. Then it's going to your rotary dryer, which is a continuous dryer, as I mentioned. So this continuous rotary dryer will be taking steam as input, and the whole body will be rotating. And from one end to another end, the grain will be moving with a slow pace, because the inclination of this rotary dryer is 2 to 3 degrees at the most. So slowly this will be moving in number of drops. So finally, the grain which is coming down, so that will be conditioned for cooling purpose. Thereafter, actually, it is sent to the rice mill where sheller, polisher, etc. All these things are there. Now, in case of true continuous process, the rapid is taken here. Here, actually, a continuous soaker cum steamer, like it's a continuous screw conveyor, where the speed of this rotation can be manipulated or maybe you can say controlled. So you can see on the top, so there is a water sprinkling arrangement, but at the same time you have some kind of steaming arrangement also pass by. So now when you are sprinkling water and continuously this grain is moving in forward direction, so possibly you can have the soaking, and the hot water will be dropped down, the excess water, and subsequently in the same batch the steam is released with the other pipe. So that way the steaming is done in this last end section. Okay, so after completion of the steaming in continuation, so this will be loaded with the help of a bucket elevator and dropped into the cup and cone dryer, as I mentioned. This cup and cone dryer, basically it will be cooling down while removing some amount of moisture content. Again, the same process will continue with the rotary dryer. So this way, this process is your semi-continuous process where only the rotary dryer will be continuous operation. But in this case, the soaking as well as the steaming portions are continuous, and this portion anyway, whatever is being loaded, this will be cooling down, and further it is loaded to the next steaming step. That way, the whole process is made continuous. That's why this is considered as Jadavpur University true continuous process. Any clarifications in this particular part? Any clarifications in this particular part? No? You did not understand or you understood?
Understood, sir.
Okay. Nobody is having any clarifications?
No, sir.
Another case. So this is actually last method for today's discussion. This is called pressure parboiling method, and this process is actually very rapid compared to your even improved many of the improved parboiling methods also. The whole process is completed in 1 to 1.5 hours, including your soaking, steaming, and drying every part. Okay, so the paddy is soaked for about nearly 40 minutes at temperature of 80 to 90 degrees centigrade. Now, somebody may question, sir, you said the gelatination temperature should not be crossed. But actually here, what's being done, it is soaked in a controlled way, just 40 minutes, very quick soaking is being done. And it is just allowed to reach to that saturation moisture content only. And once it is close to saturation moisture content, it is not allowed to remain in the soaking cum steaming tank. However, this process is done under the pressure. So this under the pressure actually when you are having under the pressure, the soaking also it is quite rapid. Now the steaming is also done under high pressure compared to your conventional open steaming process. Here is actually it is done at 5 to 6 kg per centimeter square and about I think 15 to 20 psi pressure is being maintained and the steaming is done for about 18 minutes. That means soaking time is reduced to 40 minutes, then the steaming time is reduced to 18 minutes. Although 18 minutes reducing time is not a small time for steaming, but since it is done under pressure and whatever the moisture content which has gained in 40 minutes, that will be sufficient enough to complete the gelatinization process. Okay, so that means the overall you are trying to finish the process in 1 to 1.5 hours. This particular method. Now the major advantages in this process are reduction in soaking and dry time because of this pressure steaming, even the moisture content which is in the residual paddy also is less than 50%. So it may be coming to around 35 to 40%. So since the 10% reduction is there in the steaming itself, moreover actually it is a saturated steam. So that's why the moisture content is being lost. So overall, the moisture content remaining with the paddy will be less. That's why you can reduce even so drying time also. Now in this case, because you are steaming under the pressure, even the most of the paddy they split up. So once they are splitting up, so that means it is easy to remove the shell. So it is it is actually giving a kind of increased shelling efficiency. And since the kernel is much harder than your normal process, even the milling out turn, there is no breakage or maybe least breakage. So the milling out turn also it will be more overall. Okay. Now, but unfortunately, since the hardness is more, the cooking time is much more higher compared to your conventional processes. So that's why this particular method by which actually the paddy is processed. So this is not used for your cooking purpose or maybe edible purpose. So it is mostly used for the puffed rice preparation. So if you go for your normal cooking, so it will take much more time due to the increased hardness. Okay. So that's actually nutshell about the pressure parboiling method. Maybe we will discuss some of the numericals related to parboiling in subsequent classes. But on Thursday, we will be having test maybe for about 40 minutes. Okay. So any clarifications, guys? Any clarifications? Looks like this is the highest attendance so far in the entire session. Huh? 54 people are there. Guys, any more clarifications? Abhilash, Ambika, Ankit, Divyant?
No, sir, it was clear.
Okay. Okay, then if no more clarifications are there, I think so we can wind up. Just a minute. Let me that next quickly. So I'm sharing the slides. I think clarifications are not there, and I think all these slides are actually available in MS Teams notes. If it is not available, I will upload. So please prepare well for the examination so that so you will not be having any difficulty in. If you have any clarifications, even you can come back to me anytime quickly. Till 2 more days are available. Anybody has left class now? All people are there.
All are there, sir.
Okay, no, just I'll record that message quickly. Rahul, Buri,
Yes, sir.
Sriram, Somesh, Abhilash,
Yes, sir. Avilash.
Abhilash is there, okay. What
Sir,
about
Somesh.
Somesh? Somesh.
Yes, sir, Somesh.
Yeah, Aswat,
Hello. Yes, sir. Present, sir.
Ambika,
Present, sir.
Aniruddha,
Present, sir.
Ankit,
Present, sir.
Priya,
Present, sir.
Rajhans, Narayan,
Yes, sir.
Ritvik, Dandari,
Present, sir.
Divyank,
Present, sir.
Giridhari, Sansi, Sansi, Jesiana,
Present, sir.
Jesiana,
Present, sir. Present.
okay. Lalit Sai Reddy,
Yeah, present, sir.
Santosh Mudawat, Nikhil Raj,
Yes, sir.
Rajpal, Roop Raj, Sandeep,
Yes, sir. Present, sir. Present, sir. Rajpal.
Rajpal is present. Roop Raj,
Present, sir.
okay. Sandeep,
Present, sir.
Santrip Singh,
Present, sir.
Shubham Kumar, Tarun Tej,
Present, sir.
Shubham Kumar also is there. Lakoti Varan, Sri Sai Venkat Ganesh, okay. Tirumleshwar Krishna Teja,
Present, sir.
Gurudev Sahil, Rajendra, Deepak Kumar,
Present, sir.
Guglu Ritvik,
Present, sir.
Harishwar,
Present, sir.
Jayachandra,
Present, sir.
Youtraditya,
Present, sir.
Kevin Sabu, Lakawat Arvinder,
Present, sir.
Mayank Uprati,
Present, sir.
Mukesh Babu,
Present, sir.
Neil Pratap,
Present, sir.
Patlavat Vinod Naik,
Present, sir.
Himashri,
Present, sir.
Raghav
Present.
Sharma,
Present, sir.
Rajiv Haldar,
Present, sir. Shajib Haldar.
yeah, fine. Sanjeevani
Present, sir. Present, sir.
Ratashwa,
Yes, sir. Yes, sir.
Gaurav Jambar, Sheikh Mahil,
Present, sir.
yeah, Sitaram,
Present, sir.
Smriti Mahalakshmi,
Present, sir.
Mahesh,
Present, sir.
Deepika Srevia,
Present, sir.
Utkarsh,
Present, sir.
Vankudot Prashant,
Present, sir.
Banvi, Nikita,
Present, sir. Present, sir. Sir, Bhanvi present.
Present, sir.
Yogesh,
Present, sir.
Satish, Singade. Satish. Mega Shrita.
Present, sir.
Dawal Samir.
Present, sir.
Present, sir. Present, sir.
Ritvik Jha.
Present, sir.
Just last cross check. Sriram, are you there? Giridhari Sansi,
Sir.
are you there?
Yes, sir. Sriram present, sir.
Sriram present, okay. Giridhari Sansi, Modawat Santosh,
Sir, Budavat Santosh present, sir.
yeah. Shubham Kumar,
Sir, present, sir. Subham present.
okay, good. Vanamosri Sai Venkat,
Present, sir.
Varun Lahoti,
Present, sir.
Urde Sahib, Kevin, Saurav, Satish. Okay, so thank you all. Thank you. Stay safe and we'll meet on Thursday morning for the examination. Please remember, okay? Now no more postponements.
Yes, sir.
Thank you. Thank you all. Bye. Stay safe.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Santosh and Abhilash, you can leave so that I can close the.
Okay, sir. Okay, sir.
Do you have any clarifications, by the way? That's why you are waiting? No. Thank you.